Hello, this is Mrs. Taylor, and I'm going to walk you through a quick review of transformations using some of the problems off your study guide. So in this section, the directions say describe the transformations that have taken place to each function. And so in number 2, we have y equals -3 times the absolute value of x plus 2 plus 4. And what I want to look for is things like if a number is inside of the parent function or outside. And in this case, our parent function is an absolute value, and the only term that's inside of the parent function is the plus 2. And so what that tells me is that I've got a horizontal translation, left or right, and then everything else is outside. And so let's start left to right. We have a -3 times the absolute value. So when you have multiplication, you have a dilation. And anytime the number that's being multiplied is negative, that does not affect the dilation, but it is a reflection. And so when we are looking at reflections, we're determining if it's over the x-axis or the y-axis. And the way you know the difference is if the negative is outside of the parent function, like this one, that's a reflection over the x-axis. If the negative was inside, like beside this x here, that would be a reflection over the y-axis. So this one is reflection over the x-axis. Okay? And then the next thing we look at is this 3. If there is a number being multiplied by the parent function or by the x, that's a dilation. If that number is outside the function, like this 3, that means a vertical dilation. If the 3 was inside the absolute value next to x, that'd be a horizontal dilation. So since it's outside, we are looking at vertical. And then the next thing you have to determine is if it's a stretch or compression. And the rules for vertical dilations are if the number is greater than 1, it's a stretch. If it's between 0 and 1, it's a compression. So this will be a vertical stretch. And then from there, you determine what the factor is, the scale factor. And so we'd say by a factor of, and when it's vertical, the factor is exactly the same as the number being multiplied, the coefficient. Sometimes you'll hear this called a scalar. And so it would be by a factor of 3. If the 3 had been inside the absolute value, that would have been a horizontal dilation, and those scale factors are the reciprocal, so you would have flipped it to 1/3. Next, we have the plus 2. It's inside of the function, in between absolute value bars, so that tells me it is a horizontal translation. And we need to determine whether it moved left or right, and if it's plus 2, that means it moved left 2 units. And then we also have this plus 4 at the end, and if it's outside, it's a translation, and it's a vertical translation, so up or down. And if it's adding 4, that means up. So up 4 units. So just to make sure I have covered everything, I have a negative, that means reflection. I have this 3 being multiplied by the parent function, so that's a dilation. And I have vertical stretch by a factor of 3, and then I have the plus 2 and plus 4. Plus 2 is left 2, plus 4 is up 2. So I've got everything covered. In number 5, we have the y equals 2 times x minus 3 all squared plus 6. And so it's kind of similar to the one we just did, where you have this coefficient, a scalar out front, which means a dilation. It's not in the parentheses, so that means vertical dilation. It's not negative this time, so there's no reflection. And then we're going to have a translation with the minus 3 and the plus 6. And so for this one, I'm going to start with the 2, and I'm going to say vertical and it's greater than 1, so that would be a stretch by a factor of 2. And then the minus 3 inside the parent function here, that means a translation to the right 3 units. And the plus 6 at the end is also a translation. It would be up 6 units. And so I have the dilation listed, and I have the 2 translations. So I know I've covered everything. Graph the transformation. And we're trying not to use a table, but sometimes we do need to plug in values to get some specific points. And so first thing you want to do is kind of gauge what your transformation will be. And that'll help you choose good x values to evaluate to get your specific points. So in number 11, we have a plus 4 inside of the parentheses, and that's inside the parent function. So that means it will move left or right. And if it's adding 4, that moves to the left 4. And then the plus 2 outside, if it's outside, that's a translation up or down, vertical translation. And since it's plus, it would be up 2. So what that means is you take your parent function, and in this case it's x squared, and that would be a parabola. And so this means that I can take the vertex of the parabola and move it left 4 and up 2 units and plot that point. So if I go left 1, 2, 3, 4, up 2, that is the vertex of my parabola. Because it starts at the origin, because I remember the graph of the parent function of x squared. And so I would move it according to this translation listed. And then what I can do is I need 2 more points. So if I choose one that's to the left of this vertex and to the right, plug those in, I can get the y values and plot those points and then just draw my parabola. So an x value to the right of this would be this x value here, which is -3. So if I evaluate this function at -3, I would just type it in like it's written, but when I substitute, I use parentheses. So parentheses around the -3, and then plus 4 parentheses squared plus 2. And the y value would be 3. So -3, 1, 2, 3. And then I evaluate to the left, that would be -5. And if I don't want to retype all of this, I can press second enter. It'll give me the last entry. And then I just move the cursor over to the -3 and change it to the -5. And again, it's at 3, which is not a surprise because that is consistent with the parent function x squared, and it's not dilated, so I kind of had an idea that from the vertex I would go up 1 over 1. And so then I would just connect those points in my parabola shape, and it's a rough graph, but it is correct. I have those 3 points specifically, so I know I'm good. And so it's clear that graphically I translated left 4 and up 2. And number 13, well, this is a coefficient, so it means I'm working on a dilation. And the dilation would be a vertical compression by a factor of 1/4 because it's between 0 and 1 and there's no parentheses. So I know it was vertical, and a compression because it was between 0 and 1. And so when I finish graphing, what I should have is a much wider parabola. So again, this is x squared, that would be my parent function. And so there's no translation up, down, left, or right. So I know my vertex will sit at 0, 0, the origin. So what I can do is go ahead and plot that point. And then the next thing I would do is I would move to the left and then to the right, plug those in. Well, to the left would be positive 1, if I plug in 1, 1 squared is 1, 1 times 1/4 is 1/4, and I don't want to estimate on my graph, so instead of plugging in 1, I'm going to plug in 2, because 2 squared is 4, then 4 times 1/4 is 1, so that one actually gives me a whole number. And because I'm familiar with the parent function for a parabola, I know it's symmetric, so I know my third point's going to be at negative 2, 1. And then all I have to do from there is just connect my 3 points with the U shape, and you'll have to forgive the messiness. I'm drawing with a mouse. And so I have my 3 specific points to show that I have an accurate graph, and it's clearly much wider than my parent function, which would have gone through 1, 1, and negative 1, 1. So I know I graphed it correctly. The last section wanted you to write the equation given the graph, and so you have to look for these transformations on the graph and then decide how to show those in the equation. And so when I look at this, first thing I need to know is the parent function. This is an x squared function. This is a quadratic. So I know that's going to be the basis of my equation. And it is flipped upside down, so I know it's going to be a reflection over the x-axis. So reflect over the x-axis. And then not only that, but its vertex is no longer at 0, 0, it's 5 units up. So that means it translates up 5 units. And if I start at 5 and I go down 1 over 1 and down 1 over 1, I see that those points are still maintained. So I know that it's not dilated because it's still that same distance from the vertex to the next unit point. So I'm only working with a reflection and a translation. So when I write a reflection of the x-axis, that will be a negative in front of the x, and since it's over the x-axis, it goes outside the function. So what that means is I don't use any parentheses, I just put a negative out front. And then a translation, remember that's adding or subtracting. And if it's up 5 units, well, up or down, that's a translation that happens outside of the function. And so I, again, don't need any parentheses. I just need to have my up 5 units communicated outside the function. And up 5 units would be adding 5 outside. And then all I need to do is include my function name f of x. Pretty good writing with the mouse, huh? Scoot this over a little bit. And then include my equal sign. And then that would be the equation for this transformation. And if I wanted to check my answer, what I could do is I could take my equation, type it in the y equals screen in my calculator, so negative x squared plus 5, exactly how I have it written here. And then if I go to my standard window by pressing zoom 6, it gives me the standard window of negative 10 to 10. And I can see that this is the graph of what they've given me. So I've checked my answer, I know it's correct, and so I feel pretty good about turning in my final work. And so that's just a quick review of the 3 different sections on your study guide. I hope this helps, and good luck on your test.